Proof of techniques. Prove the following assertions by direct proof. Number 1. Let x is an element of integers. If x is an even integer, which is our assumption here or hypothesis, then x squared minus 6x plus 5 is odd, which is our conclusion. So this is what we need to show. As in a direct proof, we assume that the antecedent is true and to show that the consequent is true. So proof, let's start with let x is an even integer, then x equals 2a for some a is an element of integers. So to prove that x squared minus 6x plus 5 is odd, we have x squared minus 6x plus 5 equals to 2a squared, as we only substitute the value of x equals to 2a. 2a squared minus 6 multiplied by 2a plus 5 is equals to 4a squared minus 12a plus 5. 4a squared minus 12a, and we express 5 into plus 4 plus 1, where 5 is equal to 4 plus 1. And remove the common factor, which is 2, and multiply by 2a squared minus 6a plus 2 plus 1. And it is just equal to 2b plus 1, where b is equals to 2a squared minus 6a plus 2, an integer. Since b is an element of integers, b is an integer, 2a squared minus 6a plus 2 is an integer by multiplication and addition property. Therefore, we prove that x squared minus 6x plus 5 is odd. Next is prove the following assertions in 3 different ways: by direct proof, by contraposition, and by contradiction. Number 10. Let n is an element of integers. If n is an even integer, then 3n plus 7 is odd. Again, in a direct proof, this is only what we need to show. So, proof, let n is an even integer, then n equals 2a for some a is an element of integers. Hence, 3n plus 7 is equals to 3, and then substitute the value of n equals to 2a plus 7 equals to 6a plus 7. 6a plus 7 we express it as 6 plus 1, where 7 equals to 6 plus 1. And remove the common factor, which is 2 multiplied by a plus 3 plus 1. And it is just equal to 2b plus 1, where b is equals to a plus 3, an integer, since b is an element of integers by closure property of addition. Thus, we prove that 3n plus 7, which is equal to 2b plus 1, is odd by direct proof. Next is we will prove the assertion by contraposition. If n is an even integer, then 3n plus 7 is odd. Recall that in a contrapositive of p implies q is the negation of q implies negation of p, and they are logically equivalent, that is, p implies q is equivalent to negation of q implies negation of p. And start with our hypothesis, which is our p here is n is an even integer, and our q here is 3n plus 7 is odd. And to prove by contrapositive, we assume that q is false, then show that p is also false. So negation of q implies negation of p is if 3n plus 7 is even, then n is an odd. And if you can prove that not q implies not p is true, then we can conclude that p implies q is true. So proof, suppose 3n plus 7 is even, then 3n plus 7 equals 2a, for some a is an element of integers. Now, 3n plus 7 equals 2a. And then subtract both sides by 2n plus 7. So we have the equation here. 3n plus 7 minus 2n plus 7 equals to 2a minus 2n plus 7. And then simplify. Then we have n equals to 2a minus 2n minus 7. N equals 2a minus 2n. And then we express negative 7 here as minus 8 plus 1, where negative 7 is equal to negative 8 plus 1. And then remove the common factor, which is 2, multiply by a minus n minus 4 plus 1. And it is equal to n equals to 2b plus 1, where b is equals to a minus n minus 4 is an integer, since b is an element of integers. Therefore, we prove that n, which is equal to 2b plus 1, is odd. Consequently, if n is even, then 3n plus 7 is odd. And we prove that negation of q implies negation of p is true. Then we come up to the conclusion that if n is even, then 3n plus 7 is odd. Next is, we will prove the assertion by contradiction. If n is an even integer, which is our hypothesis here, then 3n plus 7 is odd. So in a contradiction, in this method of proof, we assume a proposition is not true. Then through that premise and logic, find a contradiction that shows our original premise must have been incorrect, and therefore the proposition was true. So, proof. Suppose n is an even integer, and 3n plus 7 is even. We negate the conclusion here. Then n equals to 2a, for some a is an element of integers. Hence, 3n plus 7 is equals to 3, and then substitute the value of n, which is 2a plus 7, equals to 6a plus 7. Then 6a plus, we express 7 as 6 plus 1, where 7 equals to 6 plus 1. Remove the common factor, 2 multiplied by a plus 3 plus 1. And this is equal to 2b plus 1, where b is equal to a plus 3, an integer, by closure property of addition, since b is an element of integers. And this means that 3n plus 7, which is equal to 2b plus 1, is an odd integer and cannot be even. So we proved here that 3n plus 7 must be odd.